next week in lecture. So one of the checkpoint questions, which I didn't even realize I hadn't finished coding until last night about 10 o'clock, was about circular motion. So I guess the first thing I want to remind you of is acceleration's a vector, and it's the change in velocity divided by the time. So if I'm moving in a circle like this, but I'm moving at a constant speed, what's my acceleration? Or do I have a non-zero acceleration, I guess is my question. Yeah, you want to say no, but here's the deal. Your car actually has 3 accelerators on it because velocity has a magnitude and a direction. So you can change your velocity and consequently accelerate if you name one thing you can do in the car to accelerate. Speed up, so hit the gas pedal. So that's one accelerator. Okay, what else can you do? Okay, but like we're going to be on a flat surface, and you're going to control it within the car. You, the driver, control the acceleration. So gas pedal, that's one of them. What's another one?
Turn.
Brake and the steering wheel. Yep, you're both right. The gas pedal, the brake, and the steering wheel. So I did not emphasize this aspect of acceleration, this changing direction nature of acceleration at all when we talked about kinematics or when we talked about vectors. But it's a very important aspect of the definition. So what that means is, and I'm afraid I don't have it up here anymore. Oh, did somebody leave headphones in here last week? Okay, well, I forgot to bring my whirling sphere up here. But if I swing this around like this in a circle, it's accelerating the whole time because it's changing direction. Now let me draw you a picture of that. So, I'm sorry, now do you have to put it back, or are we good?
We're good.
Okay, so at this instant, here's the circular path an object is taking, and let's say this is V1. Then, and that velocity is always tangent to the circle. Here's the radius of the circle. And then up here, it's got, if it's uniform circular motion, then this has the same length as this one, but now it's at a 90-degree angle. So those are 2 different velocities. And then, and so on here. At every point, the velocity is going to be in a different direction. Same magnitude, different direction. So one way to write that is to say V1 absolute value equals V2 absolute value equals V3 absolute value. And what's, or another way to write that would just be without the vector symbol. So these V's are the instantaneous speeds at these 3 points on the circle. And uniform circular motion is sort of peculiar because it's a situation where you have constant speed and constant acceleration. and I'm going to say constant magnitude acceleration. Because the direction of the acceleration changes in the sense that it's always toward the center. But when it's here at position 1, it's going to be to the right. And then when it's up here, it'll be down toward the center. And then over here, it'll be to the left. Those will be the accelerations. Okay, and now just think about it. Newton's first law says an object wants to maintain its state of uniform straight line motion. So when the object is at position 1 here, it wants to keep moving in a straight line toward the top of the board. That's the law of inertia. But the way we get it to keep moving in a circle, it's sort of like it has to keep being nudged toward the center of the circle. And that's what the direction is. So if you want to go, for instance, from this position to this position, it's easier to see that it's toward the center. So to get this one so that it's in this direction, that takes an acceleration toward the center of the circle. Okay, so I just need you to get a feel for that one, okay? Uniform circular motion, only situation where you're going to have constant speed, constant magnitude acceleration toward the center. Now, in physics, acceleration toward the center is called centripetal acceleration. Do not be saying centrifugal to me, all right? That's actually a fictitious force. So if the word has an F in it, that's fake, fictitious, not real. Do not use that word. Centripetal, think of the P as pointing, center pointing. Okay? Centripetal acceleration, always toward the center. Now I know that you guys want to think the acceleration is outside, because if you've ever been swung around in a circle, you know you feel like you're being thrown outward. Actually, you're being pulled inward. And we'll talk more about that in lecture. Okay, so I'm going to pick a couple formulas out of the air, although one of them I'm going to have you help me with. So first I need to define something called the period. And it's a capital T. The name of it is period. And it's the time for one complete, in the case of circular motion,